In the previous video, we were discussing search processes, specifically how a human mind searches for something versus a machine. Let's say you lost your cat and are now looking for it. Assume you are in a room full of objects and you were looking for this particular cat. Which one of these objects do you think you would notice first? Given that you are holding in mind this particular cat's image, you may notice first the towel, which has a similar color and texture. This is an example in which the cognitive search a human performs is directed by the object they are searching for. A machine that doesn't have such a mechanism will not have its attention drawn or biased in such ways. Now imagine that, sadly, you didn't find your cat in your house. Like the loving pet owner that you are, you would now proceed to search for it on the street. You remember that down the street, there's a board where people put up signs with things they lost and found. You walk towards the board and look over the signs in a hurry to see if anyone has seen or found your cat. Here are the ads that you would be looking at. Which one of these ads do you believe you would look first at, or maybe do a double take at? It is quite likely this ad would draw your attention. Why? Because the word hat is a bit similar to the word cat, and because now, knowing that you have switched context, you are not searching keeping the image of a cat in mind, but some representation of text that could describe it. Humans, natural cognitive systems that is, are very good at doing these context switches and searches naturally. What if, when I said you lost your cat, I meant a different kind of cat altogether? Let's say your cat was of a slightly different stature. Then your brain will notice, in exactly the same context, quite different things. A texture-based search would ignore the towel and make the vase a very salient object. How would a machine deal with this? A machine that doesn't have any cognitive filtering mechanism implemented would probably search the room exhaustively. It would also need to look through the entirety of the text on the adverts board, searching the text from left to right. In cognitive AI, we look at many of these skills that natural minds have and we take for granted. Because intelligence is not just about solving complex problems, but about many of these mechanisms connected to attention, perception, memory, and others. The way natural minds work is quite fascinating. In the next video, we'll see how scientists, including psychologists and computer scientists, have thought of the mind and what it takes to build one. But first, let's recap. What are the correspondences between an artificial intelligence mind and a natural mind like ours? The input and sensors of a machine roughly correspond to perception, attention, and senses of the human mind. The data in AI corresponds to knowledge and memory in our minds. Algorithms can be compared to cognitive mechanisms and processes. And output in AI is like the action, decision, or response that a human mind has. If you wanted to build a cognitive system with similar parts as the human mind, you'd need to have some form of input, like the one via the senses. Then you will have perception and attention processes. You will build different forms of memory, like short-term memory or working memory in which the information would be worked upon, and long-term memory in which the information would be stored, like in a knowledge base. You would have some form of cognitive processes and algorithms to process this information with. And there will be a possibility for output, like action, decision, or responses that the system you would be building would do. Do you believe you could build a mind? What is a mind, after all? In the next videos, we'll have a look at how people started to study the mind scientifically and what are some of the approaches that they tried. Please remember to subscribe if you enjoyed this content and want more videos.